Welcome back, everyone. This is Ted here, and we are making a Mac game from scratch, or a game from scratch, and we're starting with Mac. So I want to show you, we're on day 4 now, and we've already set up kind of a basic build process. We have also got a window on the screen, so if we run this, you can see that we have. Let's get to my folder here. So you'll see that we actually have a window for this game that we're just going to call New Solutions. Doesn't do much. It's just a big red window. Now what you'll notice, so at the end of the last one, I said we'll go into metal. We'll start going into like metal. Doing like metal view stuff, getting the basis of that. But I thought right now would actually be a really good time to talk about bundling this thing into a full application. Because right now what you see here is just a standard kind of executable, and that's fine. That can work. It's just it also it's not exactly something that you could send to somebody. It also kind of has this problem of if we close, say, this window right here, we close that, and the application, maybe the application quits, well, this extra window won't close. So it's not really like a full self-contained application in the same sense that, so I'll just show you like another build of it that I have, because this would be like the one that's more a little bit further along. So something like this, where you see what we've got is an actual application bundle, and I double click on it, and the whole thing like just launches, and I got my intro screen or whatever, and then when I've got a nice menu here, and I can click on this thing, and then it goes away. All that stuff. That's kind of what I'm talking about. And what you'll see is this is my build folder for the project that's a little bit further along, and it's got a lot of stuff in there. We'll get to some of it later, but this is the executable, and then this is the same dsym file that we've been dealing with earlier. But one thing you may notice, or you may, if you're new to software development on a Mac, or if you've kind of tinkered around, one of the things you can do is you can right-click on basically any application, and you can click on this Show Package Contents. Okay, so basically what's going on here is every application that is on your Mac is a folder. It's actually just a folder. And you can go into the application, and you can then peruse the contents of that folder. So what's in this folder? Well, I've got an executable here, right? That's the same executable. We just kind of copied it into the folder. I've got a contents directory, all right? And then inside of this contents directory is an Info.plist. Okay, now you may, if you do iPhone development or a lot of other kind of Apple development, you may have seen this thing, right? So this is actually something that's fairly common to the platform. We can open it up and take a look. If Xcode doesn't take forever, which it's probably going to, because it, gosh, like, heaven forbid, like we have extremely powerful computers that can't open a text file very quickly. So, all right, well, if one another thing you could do is just get like a quick read out. What's crazy is too, like they can quickly like read this out, but they can't like open it up in an Xcode. So you see that there's all these keys here. It's got like the name of the application. It's got all this stuff. Basically what we're going to do is we're going to set it up so that we can build the application and copy this Info.plist into the application and get that going. You kind of need that in order for the operating system, Mac OS, to just recognize that it is your thing. Oh, hey, we did open it. So this is how Xcode displays it. This is probably the view of it that you're more familiar with. So you can see all these things. We'll talk about all this other app icon stuff. That's later. You can do an icon if you want to. It's not I'll actually show you how to do an icon, but that's like way later. So these are all different things that we're going to use in this Info.plist. But it's a really important thing in order for the operating system to register your application. It's even more important on like the mobile platforms like iOS, Android, that kind of thing. Well, not Android, sorry, iOS. And I also have this like resources directory inside. I usually put this resource directory inside of my bundles, application bundle. That's another thing that you may have heard before. You may have heard of this idea of an application bundle. Well, this is an application bundle, except what we're going to be doing is creating an application bundle basically from scratch using our build script. So you see I've got all these are all my assets in this resources file. So, you know, I can play that. That's like the sound of a moose getting mad at you. So there's a bunch of stuff. I've got like, you know, the background music. So, you know, we can play all that stuff. And then I've just got all the different assets that are inside of this, you know, inside of this game, right? So obviously, you know, when you package up your game, you don't really, and you make it public, you don't really want to have these things just kind of hanging out as like WAV files or PNG files. You probably want to put it into some kind of like, I don't know, like a compressed binary file or something, so that people can't just, you know, go grab your assets, or at least something that's obfuscated so it's not easy to go grab your assets. But it kind of doesn't matter when you're prototyping. So this resources directory later on, once we kind of get graphics into the game, is something that we'll start, once we get graphics and sound into the game, that's something that we'll copy those resources into. So that's just kind of how I do it, and at least how I do it on the Mac. So we need to basically reverse engineer this thing that's called an application bundle. And what we need to do in order to do that is we're going to hop into our new solution. No, it's not new solutions. Video tutorial. So we're going to hop right into the Mac platform / build.sh. Okay, and this you remember from earlier. So what we're doing is we're going into the Mac OS directory, or the build / Mac OS directory. If we look at that, by the way, it's VEX. We'll bring up a nice like little vertical thing in NeoVim, which is kind of cool. It's like a vertical split. And we go build / Mac OS. So you can see here, this is where that's located. And then this is the output files, right? So now what we've got here is we're outputting the executable, and we're also outputting the dsim file for the debugger, right? So all we really need to do is make a directory here to start, make a directory that contains the application. So I believe the Unix command is mkdir-p. I think what -p does, this flag, I believe what it does is it makes it so that when you do make the directory and you, like it doesn't ask you if you want to delete it, or it doesn't, no, I think it's if it does exist, then it like doesn't, it doesn't tell you that it already exists or something like that. And actually, yeah. So we'll get to the other thing we want to do, which is remove that directory if it does exist. So we're just going to call it moosolutions.app, and so we're going to do that. And then we're also going to do rm-rf moosolutions.app. And basically, what this does, rm-rf, I think you may know that, but this is like a fairly dangerous command to be doing in bash scripting on a Mac. So RM stands for remove, and then -R means recursively. So if there is a directory, if you're removing a directory, then it's going to step through all of the directories and all of the other items that are inside of that directory, and it's going to keep doing that, removing things until it runs out of stuff to remove, right? And then the F, I believe, is like force. Like, don't even ask me. Like, just do it. I know what I'm doing, and I want to get rid of this, right? That's what that is. So we're going to do this. I think this will work, but we'll see how good my bash scripting is. We're just going into the Mac platform directory, and we're going to just run the build script now. And let's see. So we're going to go back, and we're going to check. Okay, so now you see this thing. So what we have now is this directory that's smoothsolutions.app, right? Great. So now we have, this app thing. And what I want to show you, I guess, is, what happens if, I don't know, a lot of figuring out what to do on a Mac is like, okay, well, what if I do this? What happens? Does this work? Does that not work? Or etc. So if we go in here and look at our build folder, yeah, so you see this, that's an application, but the operating system is like, I don't know what's in here. You have something that is named like an application. It looks like one, but if you actually go inside, there isn't anything in there. So I don't know, like, basically what the operating system is saying is like, I don't know what to do with this thing. So that's what's going on there. So to make it able to, understand what to do with it, we need to start copying things into it. And the first thing that we need to copy into it is the game New Solutions, right? So if we do this, cp moosolutions, moosolutions.app/moosolutions. Wow, naming that moosolutions is probably not the best idea for a game that I'm going to be doing as a demo. So that ran, and now you see that our executable is inside of there, right? But I think, I could be wrong here. All right, so now at least this, the system does understand that this is an application that you can run. And then if we double click on it, there's stuff we can do. But you notice that it didn't actually quit out of it just by clicking on that close button. And you see here, you'll see that it's in our tray or whatever, but it hasn't been like quit. We haven't quit out of it just by clicking on that on the window close. So that's a thing that we have to take care of. We could certainly do that. One little bit of cleanup that I would like to do. So I'm already kind of noticing a pattern, right? Like, we sure do say like moosolutions.app a lot. It's pretty much everywhere. So what I want to do is I want to say something like we'll call this just bundle, I don't know, app bundle name or something. So this is how you do a variable in Bash. First there's the variable name, $, and also like it's very finicky. Like you can't have a space in front of that, or you can't do that. It needs to be like that. And what's actually kind of nice about this NeoVim tool that I'm using is it will actually, if the syntax is right, it'll recognize that and it'll look the right color, which is great. So I believe what we can do now is we can just go just put the $. So if you put a $sign in front of there, it's gonna treat it like it's treat it like that variable. So that's cool. We can do that. And then I think it's a little bit more finicky if you actually have it in a path. So if you are putting it inside a path, I think you got to put these little brackets around it. So we're gonna do that. Now it's nice and nice and clean. So we can do that. All right. So did that give us any headaches? Looks like nope. Nope. So we're still good there. All right. So yeah, this is, I like to do this kind of thing. Notice how, you know, another thing too you could do is, since this repeats, right, like, you could do something like, basically the idea just being like, you know, don't repeat yourself. So let's build that, and then just double check that it did what we wanted to do. Yep. All right. So yeah, I like to do this. I like to do things this way. Notice that that I didn't try to like predict ahead of time what I was going to need out of that structure or what that structure was going to look like. I waited until I noticed that something was repeating, and then I said, "Oh, okay. Well, this thing repeats quite a lot. Why don't we, you know, pull that up just into a variable and then do something with that later?" Now, what I can do that's kind of cool is if I were to reuse this. Oh, another thing I just noticed right here. So there's another repeat, right? So I can pull this up and I can go, okay. So just to build the app, right? So I waited to kind of define this thing, and then, or I waited until I noticed that this thing was being used in more than one place before deciding that I need to turn it into a variable. I didn't start by making a variable and then reusing it. I like this approach because usually what ends up happening is it's a very like bottom-up kind of a way of making things, and what I find is I'm pretty terrible at predicting the future almost always, and things do eventually have a structure, but you usually don't know what that structure is until later on. And so while you're working through something, you're kind of like cleaning as you go. So you're saying, oh, okay, well, I noticed this thing is duplicated, or I noticed that this thing has a correct kind of structure, or this thing repeats a lot. Let's just take a little break for now, like clean it up and make it nice. And look, now I have something where, you know, at the very top, what I could probably do is just take this, right? And I could take something like this, more or less, wholesale, and all I would have to do is just change the name of the app. So now I have something where if I need to change the name of the game, or I decide to change the name of the game, or whatever, there's like 2 lines of code where I go and do that. So I really like that, but again, I wasn't planning to do that ahead of time. It's just something that kind of naturally arose as I noticed that this thing has a certain kind of repetitive structure. So we'll go back. You know, I just want to run that again just to make sure that it's working. And of course it is. So we're good there. Now, do we need an InfoPlist? It's kind of funny, like, I forget when you start to need an InfoPlist. You can actually run an application for a while without an InfoPlist, although I think eventually if you don't have an InfoPlist, some things break. So we're gonna I don't know what stuff breaks actually if you don't have an Info.plist. But I think the next thing we're going to want to do is go into this. Okay, I'm going to remove all this stuff here. That was just kind of my explanation of a little bit of object-oriented programming or how I think it works. So the thing that we need to do here is we need to make it so that this window, when it's about to close, also closes the application. Because right now, the way that we have it is such that when we open the application, I don't want to go through it again. When we open the application, we click on the close button, but it doesn't close the application, it just closes the window. So we want to change that. And we may also want to add like a quit option in the top corner or whatever from the main menu. We can choose to do that or not. These are just nice little things I like to have. I think if you are going to give this game to people, even as a demo, they'll get frustrated if you don't have stuff like this. So it's certainly not a full platform layer for the Mac, but it's like kind of enough. For me, it's something that's like good enough. So with that said, there is, again, and this is something that you wouldn't necessarily know, there is a function that's called just NSAppTerminate. So if I go NSAppTerminate nil, then that will just kill the app right away. So if we look at, actually, I'll just build it and run it just so you can see. So we go, okay, so we built it. And now what can you expect this to do? Well, as soon as it starts up, it's basically just gonna it's just gonna die. So that's kind of the expectation here. Just so you're well aware. Oh, wrong game. Too many things named New Solutions. Let's go back here. Okay. So yeah, it's this. I really wish that I would get. Okay, so this is gonna. You see that little flicker? It started and then it stopped. So yeah, that works, and you can look that up. So we're going to look that up just on Safari here, so you can see NSAppTerminate. Okay, so you'll see this in the Apple developer documentation. This again is something that you wouldn't necessarily know unless you knew it, and so this also has that ID. This is code that is living in like Objective-C, object-oriented land. The sender of the message, right? If we tell an app to just kill itself, it kind of doesn't really matter like who sent the message. like we're gonna kill the app. So that's just one of those things where like, yeah, I mean maybe you could do something there, but now what's interesting is there is a class called NSApplication that represents a bunch of stuff. An object that manages an app's main event loop and resources used by all that app's objects. Okay, so this is like, I wouldn't say it's necessarily the root object in the like object-oriented hierarchy thingy or whatever, but it's a pretty darn important one, and there are a number of different things that it does. I don't want to really go through all of the stuff that NSApplication does. There's just a lot of stuff. For the most part, I really don't use this. I only use it for a few things. I use it for like the most important events in the life cycle of the application. So things like I want to kill the app, right? That's the kind of stuff that I care about. The rest of this stuff, I don't really, I tend not to mess with it. So we know that we want to use this NS. There's also like this NSApp. You see this here. That's actually shorthand. Another thing that you could do is you could go NSApplication, shared application, something like that. And then you could go terminate, So that's another option. I think that works. I'll try that out. So we could try that. that works. So shared application, what's this all about? So again, this NSApp is that's just a shorthand for this, for NSApplication, shared application. I'll explain a little bit about object-oriented programming. This idea of like a variable that is attached to the class or to like, you know, NSApplication. So you know, somewhere in that code there is a declaration, you know, it's like NSApplication, and it's a subclass of NSObject, which you probably, if you know what, you know, if you know about object-oriented inheritance, which is this whole thing that I pretty much never use or try not to use at all. Basically, like there's actually NSApplication might end up being it could be a subclass of a bunch of other stuff, but it's NSResponder, which is a subclass of NSObject. So this is actually NSResponder. I don't want to spend a lot of time on this, but it's important to kind of like know a little bit about the object-oriented stuff that we do have to use. So an NSResponder is itself a subclass of NSObject, so it inherits all the properties of NSObject. In Objective-C, the base class, so the way you can think of object-oriented inheritance is anything that is a subclass of another class inherits, which is to say it also has all of the stuff, which includes state, like data that's stored in memory, and it includes functions, so which are also called methods, as I referred to previously. So the base object for pretty much everything in Objective-C is this thing called an NSObject. Now it has a few different methods. It's got all this stuff in it. It's got some state as well that's allocated in memory, and that's kind of like Apple's building block. And on top of that, they made this other thing called an NSResponder. Now that has a whole other bunch of other state and functions and data. And then on top of NSResponder is NSApplication. So NSApplication actually has some new stuff that's only for NSApplication, and it's got all the stuff for NSResponder, and it's got all the stuff for NSObject. So it inherits like all three layers of this hierarchy of stuff, right? And now you might say to yourself, well, gosh, that doesn't seem like a very elegant way of doing things. I mean, why do you need all this other state for all this other stuff that you might not use? Or why do you need all these other functions for all this stuff that you might not use? And to that point, I would absolutely agree. I think that's kind of one of the horrendous things about object-oriented programming is how it's crufty by default. It wants, like a lot of these systems are designed to just have all this extra crap. You know, one thing you may hear all the time is like, I wanted a banana, but instead what I got was like the banana attached to a monkey holding it, who's attached to a tree, who's attached to the whole jungle. And that's kind of what object-oriented programming is like, and that's one of the reasons I don't like it. Because a lot of times what I find is code works a lot better when it's simple and it has minimal dependencies. And this is not simple and not minimal dependencies. Just to quit the application, we have to create this like three-tiered hierarchy of stuff that inherits all this stuff and inherits all this stuff. Like to me, that's just not an elegant design. Unfortunately, we have to use it in order to talk to the operating system on Mac. So that's just kind of the reality here. And so that's kind of explaining what a little bit of like object-oriented inheritance. If you want to learn more about it, I'm sure that you took a class on it in school, because like everybody does, they have to. So you know, you don't need to hear more of it. So that said, you know, understanding a little bit about it, this idea of NSApplication, shared application, well, what's that called? That's a singleton, which is just a fancy like object-oriented way of talking about like what's basically a global variable. I don't know why people like don't just call it that, but it pretty much is. So there's a global variable called the the NSApplication, or the full application, and it's got this function on it called terminate. And basically, any application that you run on a Mac has this variable in there somewhere in memory, right? And it's global. Basically, anywhere else, anything can access it. So we're just accessing this global variable that represents a bunch of application state and a bunch of things that are like at the application level. And one of the things that you can do is quit the app. So that's my little spiel there. So what does that mean? Well, we obviously don't want to just quit the app right away. Like, that would suck. So we want this thing to happen at a different time. So instead, what we want is to have it happen when the window itself, when this window closes. So how do we look at the system libraries to figure out when a window is going to close? Well, probably if I was just doing this without knowing anything else, the first thing I would do is I would look up NSWindow, right? So I would go, okay, let's go like NSWindow class reference, okay? And we click on this, all right? And now what I would do is I would just look through this, okay, or look through all this documentation until I find whatever thing I want. Now you see this is a subclass of NSResponder. So just to get a window, we're making an object that's like got all the properties of an NSResponder, and like, so, is it going to use all the stuff from NSResponder? Probably not, but it's, anyway. So there's going to be a bunch of stuff that's in here. And what we're looking for is just like functions that tell us when something is about to, when the window is about to close, or like something that represents an event that, it is like when the window closes. And I'm looking at this, I'm not really seeing a lot of this stuff. And a lot of this, as I understand it, has to do with the design of Objective-C, or one particular way that Objective-C deals with event handling. So typically, classes themselves do not handle events on their own. They have a thing that's like what they do is they sort of like delegate out the event handling to something else. So in this case, NSWindow has a thing called an NSWindow Delegate, and what that is it's just kind of like a thing that handles events that are important to the life cycle of the window. Why doesn't the window itself handle that? Well, one reason is you would have to create like a subclass of the window. So you have to create like a new subclass of the window to do that. And if you did that, you would be making like a subclass of NSWindow that only does like your special window closing behavior. And then you would have to, like, if you had another subclass that wanted to do something else, those two being able to share that behavior wouldn't be easy. I don't know, it gets kind of complicated because like these are problems that happen in object-oriented land only because they designed this system to not be particularly great with handling what we would call cross-cutting concerns. So this idea of like an NS, if I was doing like procedural code, like in C, I probably wouldn't design it that way, where somehow this idea of like things, having a behavior is like a hard problem. It would, I think I would just have like, function that you call, or like a lot of different stuff could access the function. But, aside from that, so what you have to do is you have to create an object that's like a delegate, or an object that implements some function. And then that object, when it implements that function, will do your custom behavior. So in this case, that object that implements that function is called an NSWindow Delegate. And all it is it's just a thing that has this function in it. So we're kind of getting into a little bit of custom Objective-C here. So what we want to do first is look for the right event, because that's actually going to be really important. And as I understand, so these are all resize events: styling, minimizing, zooming, full screen presentation, moving, closing. Okay, so you have two options here for things you can do with something that is an NSWindow Delegate. So we can do window should close and window will close. Okay, now window should close is an event that the system calls when somebody is about to close a window, and it's basically saying, hey, somebody tried to close this window. Is there some stuff that you need to save, or some things that we need to do, or do we need to give them like a little confirmation message or tell them to do something before we close this window, right? That's kind of what that is. Now you can say, and if you look at the structure of this function, so it returns a Boolean, window should close, right? And this is the window that sent the message. So again, this idea of objects sending messages to each other. Window should close, right? So we could return no, and then the window just like wouldn't close when somebody clicks on this button up here. And if you return yes, then it'll close. Or maybe there's like a checklist of things that you want to do before, and you might want to present an alert or something before somebody closes that window. And then if they do those things, you just close the window. I don't like any of this stuff. I just always, like, if somebody wanted to close something, we close it. I don't like this idea of doing all this. Part of the reason that your apps don't close right away and they perform so poorly is because a lot of these apps are designed to not just directly do what you tell them to do. They have to do all this other crap after you ask to close a window. So we're not going to use this because we always want to just close the window. It's a game. If somebody wanted to quit the game, they really wanted to quit the game, we're not going to get in their way. Window will close. This, I think, is much closer to what we actually want. I think this actually is what we want. And so what we need to do is just copy this function, right? So we're going to use this thing. And now, in object-oriented land, we can't just have a function out here. It needs to be tied to some kind of an object, right? So we need to define an object that implements this thing, right? It implements this window close. And what I just call it is, I don't know, call it game window delegate, something like that. And it's an NSApp, so typically in Objective-C, the first parameter or the first type name after this colon is the base class, or the class that this is, the class that it's based on, and that it subclasses. So we're making a subclass of NSObject called game window delegate. Why did we pick NSObject? Well, because that is the lowest, least cruftiest thing that we could pick. That doesn't have as all this other 5 layers of stuff that we're inheriting. So we picked it because it's the most basic one that we could pick. And then if it implements a protocol, which is what this NSWindow delegate is, then you use these brackets here, right? So it is an NS object that implements the NSWindow delegate protocol. And I think what we do is we go at interface. So what this says is like, at interface just says, hey, we're about to declare this thing. And it's an object that implements the NS window delegate, and then you do add end to end the declaration for the interface, right? Yeah, so a protocol in Objective-C is basically like a collection of functions. Typically, it's a collection of functions that a thing implements. It's you can think of it like a contract. And so when we look at the documentation for something like this, it's saying NS window delegate is a protocol, right? And it'll even say that. And it's got all these functions. So basically, any object that implements this protocol may have one of these functions. Sometimes the functions are required, so anything that implements it has to have those functions. It has to fulfill the contract. A lot of times they're not required, and in that case, if they're not required, then you just kind of you don't have to. I think NS window delegate in particular doesn't really have anything that's required, so it's all just optional stuff that you can choose to use or not. So we're just choosing to use one of those things. And then when it comes to the actual implementation of them, at implementation. I forget if we actually have to put the name there. We might get a compiler error. So this is just saying, okay, you created an interface for it. Now let's actually implement one of those. So there is a class that's like this. Its subclass is NSObject, and it implements NS window delegate. And when we implement it, we're gonna override this window will close. We're gonna use this thing right here. So we're gonna do something inside of this function. And the thing that we're gonna do, of course, is we're gonna kill the app. Because when the window closes, we're out of the app. We're done with the game. We don't want to do anything else, right? You may not need to put the word class. I forget exactly. I'm rusty on Objective-C because I don't really use much object-oriented programming. So now what that means is we need to make one of these things, right? So we need to do game window delegate star window delegate equals game window delegate alloc init. And you don't really, we're not creating any kind of custom initializer for this thing because it doesn't need any data. It doesn't, it doesn't need stuff. It just needs, it can just initialize on its own. It does allocate a little bit of memory, and the memory that it allocates is specifically for an NS object. That's all. That's what it is. So whatever state is stored with the base NS object, that's what we're getting here. And then what we do is we go window set delegate game window delegate. Just window delegate. So that all that does is remember that in object-oriented programming you have to set a property, or you have to use accessors. So we are using a setter because you don't have access to the actual data. There is a struct in memory that has there is a place for this window delegate, but we can't access that directly. What we have to do is call one of these things called a setter or a property access that kind of like opens the gate for our window delegate to get into the window. Now this, let's try this out. It may not compile because I am fairly rusty with Objective-C, but we'll see where we made some mistakes. All right. Class is a keyword. Okay, so that's probably something we can't do. Probably, I think I also need to like put this thing at the end. I forget the rules. Let's try this again. Okay. Ah, that worked. All right, so just one compiler error. Okay, so just didn't put a semicolon there. That's fine. I can deal with that. Okay, that works. Now, what will this do? Let's run Moose Solutions. Okay, so now Moose Solutions is running, right? And you can see that it's in the taskbar here. Now, if I quit it, or if I click on this, it goes, it leaves. It's no longer running. So that's pretty cool. And again, this is just something that is fairly easy to do. And I'll talk about a few more things, but you'll notice a few things. So one thing is I just kind of have this here, like you can actually do that. So a lot of times what you will commonly see in most iPhone application code or Mac application code in Objective-C, they'll go through this process of like, oh, we got to have a header file for the interface and an implementation file for the implementation, and like I hate that. I don't think it's like a terrible practice necessarily, but a lot of times it does make it a little bit more annoying to like crawl through an application or crawl through like code, especially when you're dealing with stuff that's kind of like used pretty in close proximity. I eventually end up moving some of this stuff out into a file, but I'm actually totally okay with having like a class declaration and its implementation is in the same file, and or to have like, if there's a bunch of them, just have like, well, I don't usually have like more than a handful of objects in a Mac application. Like I said, I only use enough to get like the basic functionality of the operating system in place, and then I pretty much don't touch the rest of that stuff. But usually I only end up having a couple thousand lines of object-oriented code anyway, and it's all just in this one file. So I don't really ever bother to like move that out. So that's just something to think about. And again, I've kind of drawn the line here. Just the operating system is not something that we really control. I can't, I can't go to Apple and be like, I don't like object-oriented programming. Like, you should change. Like, that's a very long process that I'm probably not going to be able to influence just alone. So this is just a thing that we deal with, right? And we try to minimize it and we try to contain it as much as we can. This is like the part that we don't have a lot of control over, and that's all that is. So with that said, one more thing we'll do is we'll just give this an Info.plist, because why not? So a lot of times what I do is I just copy my Info.plist from some other projects. So what I'll do is I'll just make a directory here that's just called resources. And this is inside of my Mac platform directory. And then what I'll do is I'll just like copy, I'll just make, I'll just make an Info.plist. So plist. And now we're inside of that Info.plist, and then what I do is I just go and I copy it from another file. So I'll just copy it from a different game. I'll copy it from Moose Solutions. So I just have one of these, and then I just copy it for every single one. And yeah, so this also has that resources file, game Info.plist. You can hit capital V, capital G, Y, to basically yank the contents of a file. So set file type equal to XML. Okay. So this is our new, actually this is basically going to be the same thing. This is our InfoPlist. So it's kind of what I was showing you earlier. What's the bundle name, new solutions, what's the name? So we're not going to change any of this. Basically, we're just going to use that. Now what we want to do is we want to copy that into the bundle contents slash we're going to copy that into our bundle. So we need some kind of CP line here, right? So we're going to take this InfoPlist, we're going to copy it into the application bundle. Already what I'm noticing is that the Mac platform layer has a structure, right? So we're going to just use that. And we're going to say Mac platform, because I use this already, layer path equals that. And then now that we have it, we can just use it from. Now this is what this is it's the location of the Mac platform layer within the remember we did this push D to get into our build directory, and then we did this pop D at the end to get out of it. So what this is it's actually the Mac platform layer path from inside of, I should actually say this. From inside of the build directory, right? So because this is a relative path, it's going to be, the location of the Mac platform layer path is going to be relative to where you are. Well, if we are in the build directory, then this is where it is, right? And so we can use this variable here. So what we're going to do is we're going to copy from the Mac platform layer path /resources /info.plist, and then we're going to copy that into the app bundle name. Yeah, app bundle name. Oh, gotta have our $sign. App bundle name / oh shoot, you know what we need to do? Yeah, you'll see. I think it's, yeah, because it's it needs to be in the contents file, or the contents folder. So let's take a look at that. Pretty much any one of these. So I'm gonna go back to this. This is the actual build for how the game is currently. If we go into show package contents, click on so it's contents /InfoPlist is where that is, right? So it's contents /info.plist, right? And what we're going to do first is we're going to go, what we actually want to do when we make this thing is we want to make this thing /contents. So if we don't make the contents directory, then you can't move something into it. So let's give this build a shot, shall we? See if that works. Don't have any errors. Okay. Let's see if we got what we wanted. Okay. Okay, video tutorials. New solutions, and then we'll just right click on it. Contents /info.plist, right? So now we've got an InfoPlist, and we've got the actual bundle in there. So is this ideal? You notice that some of this stuff repeats, right? So one thing we could do is we could make another one that's something like, I don't know. I mean, you can get to a point where you're like making variables for all this stuff just so like nothing ever repeats, and it's totally something you can do, but it also just gets kind of to be too much. And actually this works just fine, but you can see how we're doing like /contents a little bit much. If there's a lot of stuff that we're removing, I might be inclined to turn that into a variable or do something, but I think I'm just going to leave it for now because it can get to be just a little bit much. And I actually like seeing things from the root directory all the way. So to me, this actually is a little bit more readable, even though it is repetitive. So I'm going to keep it. And yeah, that's that. So that is doing the basic application bundle sort of stuff, and also making it so that when you click on the window, it closes. Another thing too that I'll show you is throughout the course of working on this thing, eventually there's going to be a lot of other stuff that we will copy into the bundle. So other things in my bundle, I believe that I have, yeah, so one of the ways that you can use Apple's rendering language or shader language Metal without having to like do a ton of automatic stuff, you can pre-compile the libraries for your shaders, and then what you can do is just copy those libraries right into your application bundle, and then you'll have access to your shaders and stuff inside of there already without having to do anything like while the app is running. So that's one thing that I prefer. Basically, at the start of every compile, I like compile the shader libraries and then I copy them in. So we will be copying, aside from just the sounds and the pictures and the music, whatever. We'll also be copying like shader libraries. So yeah, and that's it. I think on the next one, sorry for this. This is a bit more of like a cleanup kind of a day, but what I think you'll like about this is that now it sort of feels, like you actually have an app. It's an app thing. It's not just like something where it opens a terminal window. Like this is an app that you could just share with somebody. You could run it. It doesn't do much, but it's like a full app. So it's just kind of making things a little bit nicer, so that when we go into the next part of starting to set up Metal and telling it to draw, we can do that with relative ease. So I will leave you now, and if you have any questions, thoughts, concerns, definitely list them in the comments. I will certainly address them, and yeah, thank you, and happy game building.